Hello. Today is July 17, 2024. This is Workgroup Serving weekly meeting. Welcome, everybody. Today on agenda, we typically start with workgroup updates. On DRA, there is not much updates, like work is happening, the same scope, the same everything. Failure propagation in a pod status cap that I'm working on, it's a little bit delayed because I was busy past week, but PR should be out this week, couple days. And for DRA, PR review is going on, so should be okay. John, do you have anything to add?
Sorry, I just joined. So on the DRA PR, yeah, I mean it's huge PR, but we're making good progress. Yeah, so I think we're on track. We're on track to get that merged, and we will need to start. We're almost to the point where we can start getting like some other reviewers scheduling and other folks into review right now. But yeah, it's an ordeal, but we're getting there.
Yeah, Clayton made a comment in the chat. Yeah, it's a huge PR. Okay. Next is workstream auto scaling.
Yeah, and Ray couldn't make it. Yeah, Ray couldn't make it. Just a quick update. He said he was going to schedule another meeting. He suggested a couple topics like benchmarking to baseline and measure improvements, what we can do there, as well as we haven't really followed up from Xiaozhen's presentation. So I think there's a lot of good stuff in there that I know I've been commenting on the doc and having some discussions. So I think there's a rich fuel for that continuing at workstream autoscaling.
Okay, for orchestration.
I saw that Clayton added one item. Clayton, do you want to start with your item?
Yeah, I just wanted to, I didn't know where to put this, so I stuck it under orchestration. I mentioned this last time with the discussion on disruption and spot instances and all that. So we did have a SIG-Node meeting yesterday, and I think there's general agreement. There's a couple of other things we want to do beyond my basic doc that haven't been recorded yet. So a couple CAP updates will go out. But I think this will be most impactful for serving workloads on spot VMs, especially accelerated ones. And I think it will also have an impact for graceful dose shutdown in on-premise environments, although I'm not sure it has a specific serving impact there. So if there's somebody who's aware of serving impact, again, I'm always fishing for things to improve the experience for serving workloads that we can come to. And I am a little cloud biased right now. So if I'm missing something there, please point it out. So thanks, Terry.
Yeah, and I think the blueprint also belongs to orchestration, workstream, right? So I think at least a lot of folks from the ecosystem projects have been actively reviewing the proposal. I don't know if that proposal is still active because I saw a lot of comments not being addressed yet. So if Abdullah can take a look at those comments, that would be appreciated. But yeah, yeah.
And I'll actually, Abdullah also couldn't make it. He's out for this month. Abdullah's, there was a lot of really good feedback and there've been a lot of really good discussions around it. One of the things that was an outgrowth of that, which is the last bullet on the agenda, was Abdullah suggested that we actually come up with the archetypes of the config that people would expect to see in blueprints for like standard kind of example basic kube workloads. So like, I think there's like, examples of what would you do to serve the simplest LLM on an accelerated thing? What would the YAML look like? What are the points of variability that everyone would want? What are the points of variability that only some people would want? And what are the points of variability that might be determined by the platform owner? So that would be good input to the blueprint design, but it would also be useful as serving as examples that would then inform things like the DRA group. We talked about this maybe like a month or two ago, which would trying to get to a point where we could have some example YAMLs that are as simple as possible that people could both use, but also say, here's an example of a single GPU serving. Here's an example, maybe down the road of disaggregated, multi-host. And so Jason had started on that. And so we'll get to that bullet point. So that I think is like the current status of the serving blueprint, which would be, we generated a whole bunch of really important questions about what would be in the blueprint. And so the argument now is let's articulate the blueprint without any of the other infrastructure. Like, let's just do it with the basic YAML. And that's captured in the doc that's in that agenda item.
Okay. Sounds good. Yeah, I think it's definitely good to explore additional use cases and examples, but I think it's worth to take a step back to think about the approach and the API to see if there's any agreement we need to make before we go too further down the line.
And I also think, the LLM, so we could talk about this in a minute, but the proposal is kind of focused, or what Jason was focused on was the LLM aspect of it. I actually would like to broaden and say, what does the K-serve raw deployment look like? And what elements of it are fundamental? I think there's a gap in the, I think it's always useful to review YAML that people are using in Anger and look at the points of variability. So I think that would be a follow-up item. It's not directly part of what Jason was working on, but it's there. And then collating sources of example YAMLs in the ecosystem would be another part of this, which is we should be able to describe the commonality of the problem for orchestrating the different types of serving and so forth, and have good examples out of the box. Eduardo, sorry.
Yeah, sure. No, on that topic, I do think it would be worth having a joint call, right? Like inviting the K-serve core maintainers to this call and having a broad discussion on like blueprints and how could potentially K-serve be more like the APIs of K-serve be modified for the blueprint to adopt blueprints, or the blueprints simply like contributing the ideas of blueprints to the existing APIs of K-serve, right? Like having that conversation with them, I think is still valuable. I know that there are some gaps that the blueprints is trying to patch, but it would be like a side API to a project that is already being adopted by a huge set of the community. I know there's a lot of customers that are not going into K-serve, but to me, it feels more like making an open source project better for everyone. It's worth of the time versus like having two open source projects kind of like competing with each other. So inviting them would be a good thing.
Yeah, and I think that was a part of the working group charter, was to find those points of primitives that would exist. Like K-serve is not part of Kubernetes, and so we want to be really careful to have that like, what are the things that everybody needs when you wouldn't choose K-serve because it includes a bunch of opinions? What are those pieces that everybody still agrees on and shares? So I totally think that's appropriate, Eduardo. And I think the suggestion on generating the blueprint examples was to concretely say, like, you don't need K-serve to run LLMs today. You don't need K-serve to run inference today. But we should be looking at how K-serve is deploying and how their features layer on top of that. That would constrain and it would help answer. So I think that was partially what I meant by that. What does the raw deployment K-serve YAML look like? And let's have that focus meeting under the orchestration group on, points of alignment and points of difference. Because, for instance, and I think raw deployment is the one I'm focused on because I don't think the Knative one is honestly relevant in the broader ecosystem. But the shape of a deployment for when you want to start from a well-organized foundation and take somebody else's recommendations and then run it without any other baggage on Kubernetes, I think that's like the key intersection point for this group. Justin, I think you were next.
Yeah, I think I'm next. Thank you. I love the idea. I think it'd be great to get some manifests going. I guess my question is, what do we expect that to be? Is that going to be a doc, or should we have a repo where we can put up like the K-serve manifests, the bear manifest, whatever you want to call them, right? Like, do we have a suitable repo, and what is that repo?
We don't have a repo. Jason, are you on the call?
Yep, I am in the call.
You were gonna ask for, I think that same question you were gonna ask.
Yeah, I think we'd like to request a repo, and right now there's a private one that is built on customized and templating. So Abdullah made his doc public. If we can get some feedback on that, and then hopefully we can get a repo and start having these templates posted there.
And just like, I think the process is like, I know Batch has a repo that's kind of like the batch group has kind of like anything that they like, people want to test ideas, but do it in a non-committing to long-term ownership way. Like everything that's in like the working group Batch Kubernetes STIG repo is like it's a temporary thing, but it's intended to share materials like that. Is that an appropriate type of thing for us to have as well? Does device management have one of those, John?
Yeah, that's what we did for device management, and it's super useful. So like we created a repo and like we did a bunch of prototyping in there that in order to work out the APIs, right? Before, adding one little field to a Cube API is like, touches like 40 files because there's so much to do, right? This is like, we could just do pure Go prototyping and we could iterate 3 times a day on it easily. So it's super useful. Nothing's long-term committed. Yeah, we found it to be very helpful. And then if you are like, oh, we're going to have an actual project, then you need a repo for that real project. That's, whether it's in KK or somewhere else, but like, or if it's not in KK. So yeah, but for an experimentation one, it's useful.
Should we go more to this topic, Jason, or you want to stay on the agenda?
So I think there's
Sorry, I was going to say I'm adding something on the questions, but is questions going to be part of the agenda, or is that like open questions for any meeting?
I just put questions in here because I wanted to raise the question with the and I wasn't sure what group to put it under. So sure, I think that's a question for the agenda rather than a question outside the agenda.
Okay, I think I have an answer to your question, but let's get there via the agenda.
For the blueprint repo discussion?
No, I'm talking about the question section on the doc.
Oh, got it. Okay, yeah. So there's an ask for a repo. Is there someone who objects to us? Like, is there a reason for us not to create something similar to what device management and Batch have, which is like it is the working group owned place to share code examples, place to open PRs that suggest things, and then we come up with a process for like making sure that we have a good maintenance of that. It doesn't become like a dumping ground, the structure. Is there somebody like, is there an objection to that? And if there isn't an objection to that, is there somebody who can take and own the task to do that and to come up with the structure for it?
Could that repo be kind of like an incubator for KEPs, right? Like we could have like mini KEPs in the repo that once we approve them, we as the working group serving take them to actual KEPs, right? Like I think that could be like an incubator for KEPs.
And I think it would also be useful just for sharing longer form things that you want inline comments on, whether that's config, docs, KEPs. So yeah, if Eduardo is volunteering, as John says. And if there's no objections, Eduardo, if you or Sergey could tackle that, that'd be awesome. Because I know we have to request it, right?
Yeah, it's a full process.
Yeah, Eduardo. Yeah, let's do it. Sync up offline. So.
Yeah, I know how to do it. It's
awesome, and I'll put that in the notes. All right. That was, yeah. So please read the document, and I think that's a topic for the next orchestration work stream. And we should actually come up with a framing for like what the YAML is. Jan, I don't know if that's do we have another orchestration meeting planned, or what's the next orchestration sub team?
Not yet. We can plan one for maybe next week. Yeah, I'm working on a document that outlines the differences between blueprint and K-serve. Hopefully that like clears some of the questions and we can have something to discuss upon. So yeah, I'll share once that's ready.
Awesome.
Okay, next topic is multi-host inference. Well, you added it, but I think it's more of a question to everybody, right?
Yeah. So the question was 3 weeks ago or 4 weeks ago now. I don't know. July got kind of blurry. June and July got blurry for me. We had a discussion that we think it's important to do. We did not scope it in DRA, but so there's 2 use cases, at least right now, which is there's new accelerator networks that are they are attached to the GPU or the physical machines in a way that they are a distinct network. But DRA was going to propose, there's a number of different discussions going about modeling. I think this is a serving problem, primarily for multi-host inference and disaggregated serving, which are still relatively advanced use cases. They're out on the frontier. It's more of a batch problem, but nobody's really driving this right now. Which and it's a bad problem because of multi-host training. It's super important for multi-host training, but if you're setting up the whole cluster to run multi-host training, you don't usually worry about it too much. So I feel like from 4 weeks ago, we said it's important. We should be discussing it. There's not really a venue that's taking and owning it yet. John, correct me if I'm wrong there. Maybe you're about to correct me.
Yeah, no, I think that's right. I just wanted to say what the mechanisms we'll be doing in 131 are, and then that's obviously distinct from what the requirements are. But as 132 starts to come around, it would be good to have clarity on the requirements, whether what we do in 131 is sufficient, or whether there's at least something we can potentially do in 132 if we haven't done something sufficient in 131. But just to give a quick description, in 131, the vendor of the card, or really the author of the driver, the DRA driver, can put whatever attributes they want on a given card. But how we typically expect that to be things that are about that, that GPU or whatever. But we're also talking about within the example driver, coming up with a convention where the node author, the VM architect, can overlay or enhance what that driver publishes. So what I'm imagining here is that as a VM author or a physical machine author, right, you've got 8 cards in here. You're attaching the first 2 to this high-speed network, the second 2 to this high-speed network, the third 2 to this high-speed network. NVIDIA's driver, for example, wouldn't know about those external connections. So the idea would be that the node author could just drop a file into the node, into some specific place, and then the vendor's driver would pick up that file and augment the attributes they associate with the GPU or the device with the node author's input, essentially. That should be sufficient to say, paint this GPU with this NVLink domain or rail or whatever you call it. It's not sufficient to do the kind of multi-host, like a multi-host workload controller could then say everybody needs to be attached to the pink rail, all the devices, in order for this to work, or in order for you to schedule this. You wouldn't be able to say everybody must be attached to the same rail unless that's something implemented at the higher level controller layer, right? The distinction between an explicit value and a common match. We're doing common match within a node, but not across nodes. So those are the kind of things I'd like to get to eventually, but I need help from this group.
Great. Whoever's next, sorry.
Yeah, so I'm happy with you just said, because it complements what I was going to say. So a couple of years ago, I ran an experiment with the Livermore National Lab, where they were running Kubernetes on a 1,000 node cluster, and they needed to optimize when they were running MPI jobs, right? Like they were playing with, we were playing with the Kubernetes scheduler plugin. And what we end up defaulting is, when we were preparing the cluster, we run a customized MPI job that will kind of like speed out a matrix of network topology for each node. And then we will use this matrix to create labels and annotations using NFD, right? That NFD is a Kubernetes 6 project. And using that, we managed to optimize in a good way the MPI operator, right? Like we, as I'm putting there the link to the paper, we managed to achieve like extra performance via the MPI operator, just because we were creating these network topology labels, and we could allocate MPI jobs on nodes that were closer to each other, so the MPI would be faster, right? And something that is being discussed currently at the SIG node, and I have seen Clayton comments there, is like, what if we could pass node labels to the downward API, right? So like this could complement the entire history. We agree upon an MPI way of creating this network topology matrix, and then somehow, via NFD or not, we pass these labels or this topology information to the downward API in such a way that it can be used by DRA drivers to expose, like, hey, I'm node 1, and I know that I'm close to node 3 and node 5, right? So the DRA driver could know that. One of the potentials way that we have been brainstorming is like, we could potentially have like a NRI NFD plugin. So basically, we don't need to do modifications to the kubelet and enhance the downward API. Instead, we just deploy NFD and we have an NRI plugin. And the DRA driver could use the NRI plugin to know the node labels without having to ping the API server, right? And then the DRA driver could have access to the network topology via these labels. But it's kind of like a full story.
So let's go through an order of hands, I guess. I don't want to. So whoever's next.
All right, next.
Maybe me, or yeah. I just want to help out that I think the because this is talk about the multi-host, and the multi-host TP auto scaling has already been supported in the array recently. Yeah, and so we work with the GK team closely, and we are currently trying to find some real use case. So if you guys are interested in that, just reach out to me, and we are currently working on some like a documentation, something like that, and want to onboard some use cases. Yeah, because like currently I think for inference we don't have a very clear idea about use case, because I think almost all the models can put in a single node. Yeah.
Well, I mean, Llama, the news sites are saying Llama 3B 400 billion is coming out next week, so there's going to be a whole bunch of people who care about.
Yeah, I think this is one of our targets, and I think if Llama 3400B is out, and because something like the VOM only support like the FPA for now, so if it doesn't support integer flow, so I think it require multiple hosts. Yeah, but I am not sure will it go to the routes that use the support INT flow, or will it use the multi-host? Yeah, so I think it's pretty exciting to see how this is going, and but I think we currently support it. But absolutely that we want it to use the multi-host for now. Yeah, so if you guys have any use cases, yeah, it's very helpful for us.
And I'll note that in the docs, Zhezhen.
Cool.
Yeah, for the network issue, I'm just curious, like if people use cloud, how to achieve that? So I think in our like on-prem data centers, it's pretty easy to node annotate the node with the L2 switch, like or mini pod or all those like technical the network details. But in cloud, normally when we claim the nodes, we only know, okay, that's probably in single AZ or in one placement group. In that case, I think a lack of enough details like on-prem data centers, right? We exactly know, okay, does it come from the same rack or come from the same mini pod? So in that case, I'm thinking like, so how to make the like network, like high-speed network labels available on the node? Is there a feasible way?
So I think this. So my response. I think John's gonna say the exact same thing, but I think my response to Eduardo is you can do it with node labels. I think just like you're describing.
Right.
I think from a cloud perspective, there's a lot of hesitation to expose the full physical details of the infrastructure.
Yeah.
Wearing my cube hat, I'm also concerned about node labels because node labels aren't standard. And it is extremely difficult to standardize node labels in a way that you could define a workload that says like, I am a replica and I expect to be and again, like this may be too early. Everybody today can make this work with node labels. The hat I'm wearing is 2 years from now. I don't like if 50% of the clusters out there have some big, models running on them and then some small models, which again, that's somewhat that's optimistic. Like I love this whole LLM thing. It's awesome. But in that world, should everybody have to agree on a set of node labels and mark all your physical infrastructure with node labels on every single node and every single environment? And then we have to define a standardization of the different levels of topology in order to do that. That feels anti-Kubernetes. So at least like looking forward, but Eduardo, I would point out like something still has to define the high level interface so that the problem is, I say, these 5 pods should be on a high speed network. Sorting out how it's solved, that high level API is kind of what I'm focused on, not how we achieve it. And it might be too early for it, but I think my argument then comes back to there's nothing that prevents us from just using, having recommended approaches for nodes right now. But I guess I'm leaning a little bit towards, especially for batch, since we already have the aspects of this showing up in batch, and it's much more complicated than just put all these together. It's, the ranks, it's the, there's not going to be a flat network. We can't assume that. Cube assumed a flat network. So I think I guess I'm trying to generate the discussion that puts in what is the minimal set of requirements that we can be confident of right now that would allow you to mostly not care about this as a consumer and leave it mostly up to the admin team. And I think node labels and layers of indirection around node labels are a perfectly adequate solution. So I'm kind of trying to test where we are.
I mean, I think DRA is also an answer for this, right? Because at some point, DRA is going to replace device plugins, and you could request resources, right? So if you're going to say like, hey, these 5 pods needs to be in a high-speed network, you will tell that to a resource claim of DRA, right? You as an admin will create resource claims that you can define like, hey, these are my...
That'll work for allocation, but not for
topology.
Multi-workload close topology. So like scenario 1 is all of these pods together. Scenario 2, it like have to be on a high speed network. I think scenario 2 is where disaggregated shows up, where I want to ensure that there's good enough network between these 2 workloads. And that's again, like use cases are kind of stacked where they get a little bit more further out. The second one is like the disaggregated serving, which is I am going to want high performance if the highest performance is available such that the front end and the back end can both be on the same rail, that is going to be the fastest disaggregated serving. It may be totally acceptable to say, like, if you want to do that, you got to go use node labels. I think the third scenario up would be like when you start talking about caches that are shared between serving front ends. Like you've got a KV cache, you want to have multiple workloads consulting the cache. Again, totally achievable today, but that's another scenario where, yeah, the multi-workload thing would prevent the DRA resource claims from working, because you need to be able to, as John was saying, and I'll turn it over to John, as John was saying, like, knowing that all of these get assigned to the same rail is a good first step. Then the one is, I don't want to have to say all of my pods are co-located on the pink rail. I want to say, you know, all of my pods are co-located. And then the next scenario is, I want these two workloads as much as possible to get closer. Maybe that's not a core cube thing, right? Maybe we kick that to queue or to higher level schedulers. So John, go ahead, sorry.
So
Yeah, all the points everybody just raised, I sort of agree with. I just wanted to sort of note one other thing is that, and I think I said this in my response to Abdullah on the doc, but like node labels only work when your level of granularity is a node. If we assume that nodes are going to get bigger, the GPUs and other devices are going to get bigger, then, and we're going to have mixed workloads. Now, those are all assumptions or speculations, but if we're going to have mixed workloads where some are big and some are small, like getting optimal utilization out of the entire cluster might mean whole nodes, you know, I don't even know architecturally from what I've seen the diagrams, if I understand them, like we're not doing whole nodes that are all connected to the same high-speed network. There's certain GPUs connected to different rails spread across different nodes. Like that's the diagrams I've seen from NVIDIA and others, right? Like those are the kind of requirements or architectures I'd like to see from this group, or maybe from some other group, to understand what I need to do in DRA. And then from this group, it's the things Clayton's talking about, like how will you utilize that? How do you want to ask the platform to allocate the infrastructure for you, such that you don't need to worry about details? Like
Right.
What does that ask look like? What does that higher level API look like? You don't actually care that you're on the pink rail. You care that you're on the same rail. Like, so that distinction is important. It's not necessarily something DRA can solve, since at present, DRA is single host focused, but we have to come up with a solution together.
Yeah, I think that sounds good. I think there's a few problems. Like first is, I think we should ask whether cloud like to expose such like details, right? I think that no matter we use our DRA way or label way, the prerequisite is we do like cloud does like to provide such like information. The second is how we leverage or organize those informations. And third one, I like to share, like in our internal environments, like disaggregate inference. Actually, we reuse most of the training the scheduler features we down down in the training side. For example, like the topology aware scheduling and gone. Okay, so the use case we talked like the TP or like preview and decode collocation, that could be done by the traditional like topology aware like scheduling. And yeah, I think that part, if we need more like information, I can definitely help. I'm just trying to see like any other like requirements. To me, I feel like that's probably there. Like the features we did for the training, for example, in Q or in other like schedulers or volcanoes, I kind of feel that's good enough to schedule the distributed training workloads.
So two quick things. I think on the Q question, there have been other discussions about that, and we brought that up in previous meetings. Like Q today is focused on batch, but there've been some discussions that like if you want to share capacity between serving workloads and training workloads, ideally your queues would be defined in the same place. So I think from a queue perspective, there is some interest in saying like if queue is kind of a workload aware scheduler, it's batch focused, but maybe we can find ways to standardize there that benefits multiple components. That might be one approach. That's a really good insight. Thank you. On your question about will clouds want to expose details of topology, I think there's 2 points here. I think there's a lot of nervousness of exposing too much topology means that it's harder for the cloud provider or the VM provider in many cases to still have some of the indirection it needs to be able to share resources effectively. That's kind of a separable discussion, but it's like, if I had to guess, I think long term, I think it's better if we don't expose every detail, but for the short term, I think it's, most people pragmatically are asking for things like that and doing it. So it's the pattern of the day is get really explicit with topology, but I don't think it's the long-term path or the optimal long-term path. TPUs are different today, which is TPUs are optically reconfigured. And so at least from a GCP perspective, when we think about TPU support, Abdullah commented in the agenda notes, like today we're just using basic nodes. And then when you reconfigure them, you have to reconfigure the node. That works for the VM side. It kind of implies though that the labeling and that needs to happen at the time the VM is provisioned. And so there's some aspects and like, the info there is kind of static. So node labels can work, but in other cases, like it's actually very painful, I think, for users. Like the naive approach works, but that's what it has going for it. It was the simplest thing that possibly works. I think there's a lot of challenges with it when it comes to actually thinking about workloads and achieving density, where you end up having to orchestrate all these node pools, which is exactly what Cube argued that you shouldn't have to do in the first place. And so again, that's actually an area where we've had some discussions around like how do you use higher level workload scheduling to mitigate that. John?
A couple things there. On the issue of exposing topology from the cloud, totally agree, Clayton. It's the indirection that's important from the cloud provider point of view, because it allows, oh, we're going to take that down. We're going to move your workloads. We're going to take that down, like, and do maintenance on it without disrupting you, right? Like, which we can't do if there's no indirection, that kind of thing. And so exposing all of the hardware topology kind of puts all those kind of problems on you, right? Like you have to now maintain at the layer that you're exposed to. So what I wonder is, and this might be too hard, but just as something to float, an idea to float is like, if this group can come up with those abstractions of like, what's the actual requirement? It's that you get the best performance out of this. Is there a way to create an indirection such that the ask from the workload controller layer is not a physical connectivity ask, but some sort of optimal performance constraint? Does that create a sufficient indirection such that we're not directly using node labels? I think it's probably too hard. It's probably going like it's trying to abstract something that we don't fully understand yet, and so it won't work. But just a thought. The other point I wanted to make. Oh, go ahead.
So real quick though, John, that is a perfectly acceptable answer, I think, for this working group as we explore this. Like we should explore this, but to say we're just going to punt and we recommend node labels, but we should recommend node labels, and then we should say here's the consequences of that, and somebody else, you're going to pick up the pieces for it. So I think that's an important thing that we can do. So keep going. Sorry.
Okay, and then the other point was on the just a little bit more on the DRA piece in 130. So this like take TPU topology for example. Right now we do it by node pool. You'll say you get a 1x1. You get a node that's got 1 TPU. You get a node that's got 8. You get one that's got 2x4, whatever it is, right? So there's different topologies, and all the nodes have the same topology. Similarly with MIG, right? Today with MIG, at least at GKE, we say you want to spin up a node. You spin up a node with a particular MIG configuration. So what we're going to have in 132 alpha, I mean, I'm I'm hoping. 131, we have kind of like some things we talked about already. You can kind of put information on the individual resources, and then the user can kind of construct I want these that match. So I can actually create in 131, you'll be able to say create a node with 8 TPUs, and there'll be metadata published on those TPUs for DRA to use, such that a careful user can ensure proper topology and can sub-select individual, like basically break from using all 8 for one workload to breaking it into smaller things. So you no longer need to do node pools, but it puts a lot on the user. The user has to carefully construct these DRA claims. And in 132, we hope to introduce what we call our partitionable device model. And what this does is it allows the device vendor in their DRA driver to model within the Kubernetes control plane the available partitions and the interactions between those. And what I mean those is if you take the first 1 gig MIG, you can't get the first 20 gig MIG because it's used up on that card, and it'll automatically present to the scheduler, here's 50 options for devices. When you consume one, it actually strikes 8 of them off the list for future workloads. That same partitionable model will work for TPUs, where the TPU driver can say, hey, I've got 8 TPUs, but if you consume this one, or I've got these different arrangements of topologies of TPU, but if you consume this one, these other topologies are struck off the list. So in 132 alpha, we do expect to be able to do this sort of dynamic MIG or dynamic TPU topology without the user having to express anything other than I need this many TPUs, or I need a MIG of this size, or I need a GPU of this size. Again, this gets back to what we're working on is increasing the granularity of how we satisfy requests. A node label is whole node, right, by default. So this allows us to go smaller than node label. It doesn't really go, when you're talking multi-host, you're kind of trying to go larger than a whole node, right? So the question is, does the multi-host need to take slices from a bunch of different nodes and tie them together? Or is it always taking whole node? If you're always taking whole node, node label works great, and we don't need to do any of the stuff that we're doing for DRA. If you're not always taking whole node, then we need the further level of refinement that we're trying to do in DRA. And I don't have an entirely clear picture of that right now. I know that for smaller workloads, people want fractional GPU, they want MIG, they want all of this stuff. I don't know if that's relevant to the multi-host question.
So this I think, so it feels like there's some smoke here. We're still a little early. There's lots of ways to achieve it, but we need to start thinking about it. So I guess I'd suggest we, in the multi-host work stream, we continue this discussion and somebody takes a lead role. I know like Google cares a lot about this. So my natural instinct will be to find somebody who's ultimately going to get stuck holding the bag from a GCP perspective. But if there's other people who are very interested, I know Eduardo and Joja and you both volunteered to share information. If either of you would like to drive, please jump up. I think we need to kind of come up with a position, and we should start by documenting. I think, Eduardo, as you were suggesting, we need to document how to use nodes and describe the limitations, so that as a project, there's kind of that baseline, and then we need to articulate where that gap is. And I think, John, you caught like those DRA. We'll be looking at sub-device, and then there's super device topology partitioning. And I think we need to also probably can also have the queue discussion or the volcano discussion, which is, I think, Judge, and I really like that point, which was, is the kube scheduler is a pod scheduler. We've been having these discussions about when do you stop adding features to a pod scheduler and say you have a higher level scheduling problem? And is there something we could do in queue or in batch or in this that might drive some of that higher level workload scheduling, and what would that look like? And how would we, how would we ensure that most Cube users could still benefit from it? Anyone want to drive this right now, or let's do a follow up and find someone who wants to run the multi-host workstream scheduling on this?
Yeah, I can. Yeah, I can help organize the meeting.
Okay, thanks, Shajin.
Yeah,
Go ahead.
I was going to say I'll join the multi-host workstream meeting also to start discussing this.
Yeah, I'd like to go to the meeting. I don't know that I want to drive it.
Yeah, maybe next week or the week after. This is not. So is maybe the second question that I should have asked is this anyone's burning fire? I think it's smoldering for Google right now, because we already have TPUs that are pushing this, and we want to make sure that Cube is well positioned to standardize as much as it can to reduce cost and complexity for most platform users. Is anybody else on fire with this issue right now, or know of someone who is?
I would say we are on time, right? Like, as I think you said this 3 meetings ago, is like right now the biggest I have seen, like in average, is like 2 A100s, right? Like when deploying a model. So like at least today, customers are happy with a chunky node with a lot of GPUs on that node. But as things have been evolving, I can imagine a year from now, multi-node is going to be paramount, right? Like we will have like Llama 4 or Llama 5, and that will require multi-node by default.
Okay, and I think that's a good summary. 2x beefy node is where is the GPU edge right now, but we know it'll be a problem. Okay, so maybe in a few weeks. So thank you, everyone. I was exactly the discussion I hoped, because I see a lot of different people wondering about this. So it was a great discussion. Okay, I had the next topic on the agenda, which was just the API. I approved the API this morning for the image volume source, but if anybody, I'd like to have another reviewer give the look good to me on that. So that was since we've been talking about that for, if any of the other reviewers on that, and I think that was all the topics we had. Any other topics?
We can get 7 minutes back for life.
I'm pretty sure that multi-host networking is going to take more than 7 minutes of my life away over the next few years. So, all right. Awesome.
Good. Bye.